Hi everyone, welcome to the session 4 in masterclass series for simple linear regression. This is going to be the last session in this masterclass series, and I'm very excited to wrap it up at a high note. My name is Akash Pushkar. Let me have a quick introduction. I know some of the new learners will be joining us over a period of time. So I'm an IT Kanpur alumnus, currently working as a lead data scientist with Accenture Strategy and Consulting. I have been mentoring and training students for last almost a decade, more than a decade. Has mentored around 30,000 students in GATE domain. And since my background is more inclined toward data science, so I think if you guys are aware, the data science paper has come into effect right after, I think, after October or so. So GATE exam body has added a new paper on the data analytics and AI. Let me show you. So this is just a reminder or reiterating the same thing again and again in all the sessions. It's very important that we focus on that. So GATE has added a new paper, and we have already launched a batch regarding it. Okay, and we'll go and talk about it in details later. But let me show the agenda for the day. Before I proceed further, if someone can quickly confirm if my screen is up, audio is good. Let me look at the chat. Perfect. Okay, so today I think I will be getting into the Excel demonstration, right? I will be sharing the Excel sheet, and there I'll explain, with the help of real data, some of the key things which we generally do in linear regression. That how do you approach the whole problem? Excuse me. How do you calculate beta naught, beta 1 and all that. So let me start the session with the Excel. So you will see that I have the Excel here, and this is a very good Excel in terms of the data. If you look, I'll quickly give you the background of the data. So what you're looking at, in column A is your sales. So if you see here, sales is showing some numbers 22, 10.4, 12, and so on. And the second column, if you see, it is the TV advertising. So if I make an, if maybe I can ask you guys that looking at this data, which column do you think out of these two columns should be the independent variable and the dependent variable? Please comment your answer in the chat. Anybody, any answer, guys? So if you look at this, definitely advertising actually leads to sales, not the other way around, right? Means if you're doing some, and I think World Cup is going on, and as we speak, India is playing South Africa, right? So you must have seen between the overs, right? The break, they show the commercials, right? The ads. So these ads will be definitely for some products and leading to the sales, right? So generally people do ads targeting the audience to do some sales. So that's the context of the data. So you are saying that if you are doing, let's say, 230.1, uh, uh, right, of the worth of the ad, then you get 22.1 units of sales, right? In this data, unfortunately, we don't have much information that is it in the terms of number of times ad is coming, or the amount of money got invested into the ad leading to money of sales, right? Revenue, or it is sales units. But we don't need to worry too much into it. What we can take, that take your X as the ads. So I'll just copy and paste the whole data here. See, and Y will be my independent variable, and that will be sales. So what I'm saying, guys, I'm going to predict the sales basis the ad. Can I say that? So this is your TV advertising, if my Excel is visible, guys, let me zoom in a bit. Perfect. And Y is my sales, right? Correct. Now you have the X, you have the Y. So generally what we do, and we should do all the time, find the mean of X. That's the first thing you should do in any data. So mean is going to be what? Average. Perfect. Find mean of Y, and that is what? Average of Y. So I'm showing you, which you can also do, and that is expected in the GATE exam, that they will ask you these details and you have to manually calculate it. There's no other way around, because I don't think you can use Excel in GATE paper, but I'm just showing Excel to make a point. So average of sales is what? 15.13, and average of X is what? 147.04. Sorry. Right? Clear? Now our aim is to construct the linear regression equation or least square equation or least square line. How will you do it? So if we go back to our understanding of it, right, and that's where I will revisit what we were doing, right? So if you look at the formula, and that's where I'm jumping to it, guys, remember this? Let's do one thing. Let's take a screenshot of it and place it somewhere here, okay, so that it's in the front of your eyes. Sorry. So I'm keeping it very raw so that, okay, so somehow I'm not able to, copy paste. I don't know what's going on, but let's see if I can try. Okay, anyways, guys. So what we can do, let me write the formula, and I'll write a shorthand formula for it. And I think I can write it. Yeah, thank God. So beta naught is equal to y bar minus a times b times x bar, right? Correct? Or you can just derive it here. A plus beta naught or beta 1 x. So beta naught can be y minus, you can see, right, beta 1 x bar. So maybe if I can be consistent with the equation, so you can write beta 1 x bar. And what is beta 1, guys? Beta 1 can be written as covariance of x comma y upon, come on everybody, variance of x, right? Covariance of x comma y, variance of x. That's one way of doing things, right? Or you can use this formula, which is n times sigma of xy minus sigma x sigma y divided by n times sigma of x squared minus sigma of x whole square. Both will give you the same result, but definitely it is little lengthy, and that's where I would suggest to go with the shorthand notation. And alpha I have already mentioned, which is your beta naught, is y bar minus beta x bar. Are we clear, guys? And in my formulation, beta naught is intercept, okay, and beta 1 is what? Coefficient of x. In this case, it is coefficient of TV advertising. Does it make sense, guys? Come on. So keeping this in mind, what if you can find covariance? Now, I think again, you have to go back and understand what is covariance of x comma y. I hope some of the guys already know it, right? Variance is everybody knows. What is covariance, guys? Come on. Covariance of x comma y is what? It is sigma xi minus x bar yi minus y bar I equal to 1 to n divided by n. That's your covariance. Okay, and what is variance of x? It is sigma xi minus x bar whole square, I equal to 1 to n divided by n. Clear, guys? That's your variance of x. So now these are the formulas that you have to keep in your head. Now, what I'll do, I'll come here, right? Copy paste this whole thing, and let's go to the right so that it is easy for us to operate. But we have the formula in front of our eyes as well. Perfect. Now you tell me what is going to be x minus, so this is like x minus x bar, right? So this is mean of x, right? Let's call this like that. So we will be doing what? This minus this, and you have to freeze the range in terms of Excel, right? Perfect. And do it. Similarly, we'll do y minus mean of y, right? So we'll do what? This minus this, and freeze it and run it. Now you have the difference from the mean, the difference of mean from each of the data point. Then you will do product of these two guys. You will say x minus mean of x into y minus mean of y. I'm doing all live, guys. Nothing I'm just showing as a slide. So please pay attention. So what does it mean? It just means that you have to do the product of these two guys. See? Just multiply these two folks. Perfect. Now to get the covariance of x comma y, right? You have to do nothing. You have to just do summation of this, right? Summation of this divided by n. How much is n? Guys, how much is the n? N is your data points, right? So if you see n, I think 250 records. How many are there? 200. So you have to divide by 200. That becomes your covariance, guys. Perfect. You can also find covariance like this. And let's see that if we are correct or not. See? Are we close or not, guys? This is covariance from formula, Excel formula. You can code this in Python as well from Excel, right? Are we matching? Yes. To the decimal places, we are good. Perfect. Now, once you have the covariance, you can also find variance. So let me write variance. I'll go towards the right. Now, the variance of x you have to find. So what is variance of x? I'm not going to calculate it by using the formula. I can just say, because see, in their Excel formula will not work in GATE exam. So that's the reason you have to use your analytical approach, calculate it. So this is x minus mean. So what you have to do, you have to just multiply this guy with this guy itself, right? So this is your square of this. Square. I'm writing everything very clearly. And to get variance of x, my dear, what you have to do, you have to write sum of this guy, that is your sum of squares of deviation from the data point. Perfect. And then you have to divide by n. N is 200. The variance of x can be also found using Excel. See, you can just write variance and you can use x and done. Are we matching? Yes, we are matching to the decimal places. Once you have this, my dear, Then you can write what is your slope, or we also say coefficient of X. In this case, it will be TV advertising by using the formula which I have given, and that is, come on, that is what? Covariance of XY. So this divided by variance. So what is my beta naught comes to? Beta naught, beta 1 hat, this 0.06. Okay. It looks little off, but it's okay. This is what it is, right? And I will quickly confirm the formula, because formula can be a little tricky to remember. And what is the intercept, my dear? Intercept is what? So intercept is y bar minus this value into x bar, right? That's what we are saying now. Yeah, y bar minus beta 1. This is beta 1. So what is y bar? This is y bar minus this guy into x bar, right? So that comes 6.97. So then my manually calculated linear regression equation comes out to be what, my dear? It is y hat equal to beta naught, which is this, beta 1, this is here, is what? Excuse me, guys. 6.97 plus 0.06x. If someone is calculating me with me, or you are doing later, please come back and comment your equation. Are you also matching the same? Are you also able to match it? Are you also getting the same? Okay, this is your analytical way of calculating the linear equation line, right? That is what I expect GATE might ask you with a very simple data. They might give you just 5 data points and they can ask you what is the linear equation line. They'll give you 4 options. One will be correct, right? Now, if you have to go into calculation of coefficient of determination and all that, so what you have to do, guys, you have to pick another formula, and for that you have to find, correlation coefficient first, also known as rho. So what is the formula for correlation coefficient? It is what? Covariance of xy divided by sigma x sigma y, isn't it, guys? And what is coefficient of determination, which is r squared? That is just square of this guy. Okay, it holds true. So then this I can quickly calculate. What is my covariance of xy? This divided by standard deviation. So first I need to calculate sigma x, right? And then I have to calculate sigma y. Okay, so what is standard deviation for this guy? You can quickly go for x and find. Come on. Perfect. And what is sigma of y? You can see that. It does make sense. See? Have patience, guys. Yeah. So this is sigma y, right? So now what is this value? Okay. What is this value, my dear? So write the equation covariance of xy, which is this, divided by sigma x into sigma y, close the bracket. So 90% is the correlation. Quite a strong correlation, guys, isn't it? Is it a positive correlation? Yes. Hello. So the correlation comes out to be what? 0.90. This will be in the category of strong positive correlation. So basically we are saying that doing ad on the TB is really making sense for our sales. Look at this. Doing ad on the TB is really, accelerating the sales for the business, and this can be established with a simple diagram of scatter plot as well. Let me show you guys. Can you see that, my dear? Please pay attention, right? If you focus on the data, your sales on the, so let me add something on the chat so that, let me add a chart title. So this is your chart title and chart axis, right? I don't know. Axis is already there, it seems. So on the y-axis, guys, you have the TV advertising, right? So maybe, sometime, bringing advertising on the x-axis will make a lot of sense. So what I'll do, guys, I'll keep it very simple. I'll just copy and paste this same thing, and then I will same data. I'll quickly put a chart. Means you can also go and change it, right? Now you can see that, guys, as you increase the TV advertising, can you see the relationship, my dear? See, on the x-axis, your TV advertising. Look at the data range coming from 0 till 350, and your sales is increasing on the y-axis. If you try to draw a line, my dear, please pay attention. You will see that it's a upward trend, guys. Can you see that? It's an upward trend, and that is also coming, you know, from the linear regression concept. And if you go to the right, my dear, what is the correlation coefficient we got? Correlation coefficient, it came to 0.90. Let me highlight that. How much is that? 0.90. 90% strong correlation, positive strong correlation. It means that if you increase the advertising, sales would increase. Agreed? Everybody, give me a thumbs up if you understand. Right? Now, what is going to be R square? Very simple. So R square is going to be what? I'll just calculate here. I'll take this number and I'll multiply this with, again, that's your R square, coming to 81.2%. What is the interpretation of 81.2%? It means that 81.2% variability of the sales can be accounted for by TV advertising. So suppose your variability in the sales, which is your Y, or in the overall data set with respect to sales and TV advertising, 82%, approximately 81 to 82%, you're able to capture, and you're able to use this information to predict the future sales. Now, how does the linear regression line equation will work? Suppose you say that I want to do TV advertising 1,000 times, right? See, in the whole data you don't have 1,000, right? But if you say put your 1,000 number here, how much will be your sales? You can do the quick maths. It is 6.97 plus 0.06 into 1,000. So how much is that? So it will be 66.97 unit. And look at that, 66.97 is like a huge sales. Look at your scatter plot, then you will understand. I think it will be in the end. That's how it is. The highest sales you are having 30. Now you are saying you will do 66, almost double. And in terms of your X, you are also reaching towards double. 350 double is 700. You are giving 1,000. That's where it helps us a lot. Now, whatever we have done, I'll take a step back. Whatever we have done so far, you could also do it with the help of linear regression using Excel. Would you like to teach me? Would you like to teach this to you guys, right? Means, can I show you quickly? So guys, first thing you have to do, you have to bring this using the options as an add-in, right? And you will see that you have the Excel, or see, so you will see that you have the analysis tool pack. That is something you have to bring. You have to check it and you have to say, okay, in my case, it is already done. Then if you have done it, I'll repeat my step, guys. Go to file, go to option, click on the add-ins, and then click on manage Excel add-in here, focus here, and click on go. Once you go there, you will see analysis tool pack. Tool pack is there, right? Okay. And then you will see in the data on the extreme right, please pay attention here. You will see data analysis tab is there. Now what you have to do, you have to just click on this data analysis tab. That's what I've done. Let me repeat. Click on the data analysis tab, then it will ask for regression. Then you click there, and then you have to give the input Y range. Y range will be sales. Let me give you. Then you have to go and give the input X range. You will give the X is as TV advertising. Then you can give the labels. So labels are important. Uh, then you want the output on a new worksheet. That's fine. Uh, Constant is not zero for your case, so you'll keep the constant. You can also show the confidence interval if you want, but in this case, I'm not going with it, right? And then residual is something you want to plot. If you do okay, guys, right, you will see that residual numbers are also being calculated as an output. But can you observe, my dear, your numbers are matching with what you have done manually. See, intercept, you calculated how much? 6.97, and this is being calculated. Let me copy this output, this much only, and let me place it towards my numbers. I'll put it here, guys. Now see, guys, what is my intercept? 6.97. Are you getting the same 6.97? Let me highlight. What is the TV advertising, which is your slope or coefficient of this X? 0.055. I'm saying how much? 0.06. But if you round it off, this will also become 0.06. See? Perfect. Then you have the standard error and the p-values. Can you see that? By default, alpha is going to be 0.05, right? So if the p-value is very less than alpha, so if p-value is less than alpha, then we will say that null hypothesis will get rejected. And generally the null hypothesis that it does not impact the sales means it has no relation, X has no relation or impact on Y. But here you can see that p-value is making this variable as significant, means you have to consider it, right? So far so good, guys. Makes sense? So what you have done manually, a manual calculation, you can see it is matching all of it. Look at R square value, guys. Look at this. What is R square? Is it coming 81? Isn't it? That's what I've also mentioned here. See, it's more like a validation for you guys. Okay, when you will actually be looking at more than one variable, which is multiple linear equation, right? Multiple linear regression equation. So comparing it with simple and multiple, the only difference is that you are going to see more number of predictor variables, right? Features, inputs. So there you will be not using R square, because R square can be a little bit misleading because it keeps adding the variation to the overall output, and with coming in more variables, input variables, R square can be a little inflated, and that's where you have to adjust it for to get the right you know explainability metric, and for that you will be using adjusted R square. But in this case, it is only having one variable. You will see that your numbers are almost same. See, there's no difference at all. Okay, so I'll take a quick pause here for you guys to go through it, and let me know if you need any questions, any comments you have. Not necessary that you have to punch those comments right now. Whenever you are coming to this page, and that's where I need your support, and the team needs your support, encouragement. Do like the channel, subscribe the channel, so that you get all the latest and updated learning experience on this channel. Okay, and let me get back to my OneNote to reiterate the fact that we are already running a full-fledged course for GATE DA paper targeting GATE 2024 and 2025. So those who are in first year to even in final year, you guys have a golden opportunity. And if you want to know more about the program, please come on this page, click on the live online program for the online class. For the offline or classroom program, you can click on this link. And for the notes related to this lecture, what we have done in the last 4 sessions under the simple linear regression masterclass series, you have to join this Telegram group. And yeah, do share with your friends, and keep supporting us. Now, if I go back to my second bit of the agenda, that is your probable gate question and some of the gate question which we feel that they might be asked to you guys. Okay, so let me start with the gate question itself, guys. So I'm showing you the gate question which was asked in 2022. Look at the question. So if you see in this gate question, guys, this was asked in gate 2022, recent question. And if I recall correctly, it was asked in CS paper or statistics paper. Let's go through the question. It says that a set of observation of independent variable x, excuse me, and the corresponding dependent variable y. So this is your data, guys, right? X and y. Y is your dependent variable, x is your independent variable, right? So dependent, independent. Based on the data, the coefficient A of the linear regression model is estimated as 6.1. So they know that A is given as 6.1. They are estimating for the B. How will you answer this question? Anyone? And my eyes are on the chat. I've already told you the approach. See, there are two ways to approach this question. One is that either use the formula B equal to covariance of x comma y by variance of x, or you can use the formula A equal to what? Y bar minus B x bar. Hello? You definitely know that this one is a lengthy approach. My first comment would be this one is a lengthy approach. You agree, guys? And gate doesn't give you that much time. If you don't have any option, he will go with this option, right? But here, if you look at input output, you have only 4 data points. So you can quickly calculate covariance, variance, everything. But why to do that rather than doing that? You can go and take this. This is more like an easy approach, and it will hardly take 1 minute. Let me show you. So what is x bar? You tell me. Look at this. 5 plus 2 plus 7 plus 3. How much is that? 12 by 4, 3. What is y bar? Come on. 26, 39, 40, 51, right? 26, 29, 39, 41, 51. 51 by 4. Please help me out, guys. Let's keep it like this. Now use this formula and this calculated values. A already they are telling is 6.1. Sorry about the throat. 6.1. Y bar is 51 by 4 minus B times 3. So how much is that? 3B equal to 51 by 4 minus 6.1. Okay. So B is equal to 1 by 3, 51 by 4. Right. Let's do the maths. So how much it is? 1, 2, 12.7 minus 6.1. Roughly I'm saying, guys. Okay. So OneNote has some cool features. Means you could have also calculated this 51 by 4, right? See, 12.7. Can you see this? 12.7 minus 6.1, 6.6, and then you divide by 3, 2.2, right, guys? So B is coming out to be 2.2. Gate does give you some calculator, so don't worry. Don't get jealous, right? Perfect. So the answer for B, let me validate, is coming to be, just check, guys, it should be 2.2. And let me just validate the calculation, 6.1, right? I'm just looking because 51 by 4 minus 6.1. So 51 by 4 minus b into 3, 3b. How much is x? X bar is not 9, 7, 11, 14. Yeah, that's why I was thinking. Guys, there's one typo from my side. Please change it. That will change a lot of things here. That's a small typo. So it will be how much, guys? Let me just correct it. Because my answer key was telling differently, so I need to change it. It will be b into, you have to be also very careful. So 51 by 4, b 14 by 4. So it will be how much? It will be, b 14 by 4, 51 by 4 minus 6.1. See, so this does not change anything. This is fine. So it will come after doing the math. This is perfect. So it will be coming to 6.6. So what is b? 6.6 into 4 by 14. Let's do this, guys, now. So I'll say into 4 by 14. How much is that, guys? 1.88. Approximately 1.9. Perfect. Let's move on to the next question, guys. Now, this is a real industry question I'm putting on the screen from my other screen, guys. So this is, you will love this question, man. I feel whenever I do this question, I've taken this question from the university. So look at the question, guys, and I think you should be able to do this question. You will love this question, guys. Yeah, I'm just trying to put everything on the same screen. Now, please pay attention. If you see on this question, it says on a machine that folds plastic film, right? So, you're trying to coat a plastic film, and the temperature is the one of the axis and the thickness is other axis, right? Can you see that on the graph? So obviously know that temperature has an inversely relation with the thickness of the plastic. You might have done by mistake, right? You have taken a hot iron box and put it on any plastic. Suddenly it vanishes and becomes sticky. Why? Because temperature is going to melt the plastic, right? So if you see here for 12 data points, these are 12 data points. They have given you the data points and the linear regression line. If you are able to observe, the black line is what line? This is your best fit line, or you can also call it as what? Linear regression line. And this line, my dear, is very close to the data points, the actual data points. Now they're asking in the first part they're asking, determine by looking at the figure, which of the following sets of estimates for the parameters in the usual regression model is correct. Only one answer is correct. It's a single correct answer. Let me give you that. It is single correct. So you have to just tick one of it. That kind of, that's kind of the question they can ask you, right? And then you also see they have given some values of beta naught hat, beta 1 hat, and sigma hat. Hello, are you able to follow? Guys, I'm looking at the chat if there are any questions. Now, a lot of time people ask me, what is sigma hat? Beta not know, intercept. And please answer in the chat before I answer. So you can pause your video whenever you watch, pause it and answer it. What is beta 1 hat? This is your slope, right? Intercept. And sigma hat is what? This is your standard deviation of the residues. Standard deviation of the residues. Residues what? Errors, right? Which is what? The difference between the actual value and the predicted value. Suppose I'll take a very simple example. These are your data points, right? I need to tell you this, right? And then you are drawing a regression line which is passing like this. Now, what is the deviation from this point? And maybe I can put it this point here a little far, and this point. This positive residue is here. So you can say this is my positive error, and you can say that this is my negative error. Why there is an error? Because you are far away from the original. So regression line is little away from the original or actual data points. You're not making any error on this point or this point. Okay, you're good. Error is 0. Here you have some positive error, you have some negative error. If you take standard deviation of this error and then you estimate it, that becomes your sigma hat. Perfect. So far with me. This is a very good question. And I expect that GATE might ask a probable question like this. So it's a probable question for GATE. I'm giving you, see, this is the first time GATE will conduct this paper. So nobody is sure that what will happen, right? Nobody is sure about it. So now look at this. You tell me, first of all, intercept can be 0. Kya? I don't think so. How can the intercept be 0? Look at this. They are definitely going to cut this y-axis, which is your thickness, somewhere higher, right? Intercept cannot be 0. So this option is eliminated. This option is eliminated. Intercept can also not be negative, guys. Come on. How can it be negative? Right? Negative means what? Negative means what? That if you are not giving any temperature, temperature is 0, means you are maintaining the temperature 0, not positive, not negative, 0. Your thickness is like negative. How can the thickness be negative? No point, right? So all these options are gone. Now you have two potential options, either option 3 or option 5. Listen to me. In option 3 and 5, you will see that this is same. Beta 1 hat, yeah, they're also good, right? Same. The only thing different is what? Option 3 says sigma hat is 3.6. And option 5 says sigma hat is what? 36. How can it be 36? Look at this now. What is the standard error here? What is the deviation of the residues, right? Standard deviation. The error is like marginal. So it can be as high as like 2 unit, 3 unit or 3.6, right? It cannot be 36. 36 means, you know, your data is here, your line is going like this, somewhere here. Then you can expect 36. Are you getting my point, guys? But the linear regression line is very close to the data points. Definitely, intuitively, we'll go with 3.6. So the right answer becomes option 3. You are also going to eliminate option 5. I hope you like this question, guys. Cool. Let's move on to the next question. This is the question, second question of the same data, right? So what I have to do, I have to take it the screenshot of the graph as well. Again, now they're asking which one is the most, sorry, which one is the only possible correct answer? And that's the last question. Then we will wrap it up for the masterclass series on linear regression, right? Now, if you see, they are telling that proportion of explained variation is 50%. First of all, proportion of explained variation is represented in a fancy word called R square, and the correlation is R or rho. You have seen me doing it, guys. Come on, yes or no? Now, you know that since you are so close to the data points, you are explaining more than 50%. There's no doubt about it. And the correlation is strong but negative. Can you see it's a declining trend? Hello? It's a declining trend. And I have taught you this. You cannot say that, we have not gone through that. Let me just quickly show you the notebook for session 3. If you see, right, I was showing you different value of correlation. And see, this is your negative correlation. Read perfect negative correlation because the line is on the data points. But it is slightly off, as you can see in this diagram. Then what you can say that correlation definitely is not positive. It is negative. So this option is gone. This option is gone. Negative, negative, and this is perfect -1, but not every data point is on the line. So this is also gone. So either the option will be option 2 or option 5. See, you have to understand this, right? Now they're telling that in option 2 that proportion of explained variation is just to 0%. Means, are we saying that regression line does not explain any variability in the data set? That bullshit, right? I mean, that's not correct. So this option also gone. Definitely it will be explaining somewhere close to 80, 90, 90%. And as you can see in this option, they are saying that, right, 96% is the R square, and correlation is how much? Rho or R is how much? 0.9 minus 0.98. And actually you can use this to calculate. I have taught you, So what you can do, you can say minus, see minus minus will become plus, but you can write minus 0.98 into, see I'm doing it, minus 0.98, and if you just say equal to, see it's coming now 96.04. See, so guys, I think we have completed the masterclass series on simple linear regression. Keep coming, watch this session, take a sense of what kind of question they'll ask in the GATE exam. Just to quickly recap, you know we started with overview of machine learning in session 1, right? And then we got into what are the different types of machine learning, so supervised, unsupervised. Since we were talking about simple linear regression, which is a supervised machine learning technique, we started with the intuitive idea about linear regression, where I showed you a very nice way of demonstrating that how you can try to fit a line which is going to minimize the sum of square errors as minimum as possible. Then I invoke the idea of that why we can't use modulus function, because it is not differentiable, and to get into the minima maxima concept you have to differentiate. Then we estimated the beta naught and beta 1, or you say alpha and beta. I differentiated, the loss function with respect to alpha and beta, and got to the formula of beta 1, alpha and beta, or beta naught, beta 1, or A or B. These are all synonymous names and notation for it. Then we got into that, what is the understanding of the sum of squares in the yesterday session. So yesterday means the third session 3, and sum of squares for the regression was, sum of square total, regression sum of squares, and sum of square error. These are the three mains. Sum of squares will explain the variability uh, in the data set. And then we reached to the concept of R square, and then I showed you that how R square can be related to the correlation coefficient, one way of looking at it. Or you can use, sum of explained variance divided by the sum of square total variance. That also gives you the R square. There are two ways to reach at the same. And today I think we focused on how to demonstrate the, quickly using an Excel to do the linear regression equation, calculate like by using your hands, validate with the linear equation formula on Excel, and then I took some questions to complete it. Make sense? So that was all about uh, simple linear regression from me. My name is Akash Pushkar. You can call me APC, and keep supporting us as I have mentioned again and again. And I strongly believe that those who are going to watch these series, right? So we have 4 session masterclass series on simple linear regression, right? Go and complete. That's my sincere request, guys. If you don't complete all the sessions, you'll not get a full picture. And if you really want to start seriously preparing for GATE exam, so please click in the description. You will see the live online program and classroom program. You can click on that link and get more details about it. And the notes related to this session, you can find it in the Telegram group. So that's all about me. That's all about linear regression, and that's all the info we could have provided you. So thanks for all the support. Keep supporting us. Keep